All right, so I was just going to walk through the uh, three or four problems from the review. Um, First thing, remember you can use your TI-83 calculator on the entire quiz, so that should be a bit of a relief. So for this first one, I want us to find the factors, x-intercept, zeros, number of zeros, and behavior, local max, mins, where f of x is greater than 0 and where f of x is less than 0. So the first thing we're going to want is a graph. So I'm going to go ahead and graph this x cubed minus 1. I can go ahead and graph it. And I'm just going to drag and drop this over here. And the first thing it had asked me for were my zeros. So you can find the zeros on your calculator, and you do that simply by going to second trace. You're selecting number 2, 0. It says left bound, so you go a little to the left of your 0, as close as you can, and then a little to the right of your 0, then a guess, and hit enter. And you'll see that your 0 is at 1. So my zeros, so 0 at x equals 1. So if that's my 0, that's also my x-intercept. Same thing. X-intercept would be when x equals 1. The number of zeros is clearly just 1. Simple enough. All right. The factors, we would just write this in factored form. So a factor would just be x minus 1. And that's that. All right, when we look at M behavior, remember that's what we're talking about when we say x approaches infinity, f of x approaches, and as x approaches negative infinity, f of x approaches what? So we look, as we go to positive infinity, which is to the right, our graph is going continuously up. My y values are increasing, so f of x is going to go to infinity. And as x goes to negative infinity, to the left, you can see your y values are going down to negative infinity. All right, the last thing you would want to do is look at your local maxes and mins. A local max or a min is when the graph changes direction, so it goes from increasing to decreasing or decreasing to increasing. This graph has none because it doesn't change direction at all. It's always increasing. The last part of the question asks when f of x is greater than 0 and when f of x is less than 0. And basically all we're doing here is saying, okay, when is my graph above the x-axis and when is it below? And I'm using x values to describe this in interval notation. So here's where I hit 0. So that's 1. So from 1 to infinity, my graph appears to be above the x-axis. So I would simply write 1 to infinity. And then it asks when f of x is less than 0, and that's from all the way from negative infinity to 1 is when my graph is below the x-axis. All right, so that answers all of those questions for that one. Draw a line here so we don't get confused. And for the next one, we're going to go through and do the same exact thing. So you go to y equals, enter in negative x cubed plus x squared plus 4x. And then we can graph this. We'll see what we get. And this one looks like it has 2 changes in directions. We have 3 zeros. So this we're going to have a little more to work with. But again, it's really just the same process. So first thing it asks for is our zeros. You can see we have a 0 here, here, and here. And we're just going to need to solve for those. And we do that using the trace function on our calculator. Again, the 0 is the same as the x-intercept. My number of zeros I can tell just looking, which is pretty obviously 3. All right. So I'm going to go back to my calculator, and again, I'm going to do second trace. Number 2 for my zeros. Go left bound, so slightly left of my 0. Slightly to the right of my 0. Guess. and it tells me it's at negative 1.56, so I'm just going to round that to negative 1.6. So x equals negative 1.6, but that's only one of my zeros, so I need to go back and get the other two. So again, second trace 0. So go left bounds, and this is pretty obviously going to be 0, 0, but I'll go ahead and do it anyway. So 0 is another 0. And finally, I'll go one more time to this last one all the way to the right. So I'm slightly above, slightly below, guess. And I get 2.6 approximately. I'm just rounding. So 2.6. So those again are your x-intercepts as well. My factors would just be x plus 1.6, x, and x minus 2.6. All right. Next thing we need to look at is our end behavior. So again, as x goes to infinity, f of x goes where? And as x goes to negative infinity, f of x goes where? So here, as we go to positive infinity, as x goes infinitely to the right, my y values are going down towards negative infinity. And as my x values go towards negative infinity, infinitely to the left, my y values are going up to infinity. All right? The last thing you would need to look at here is your when f of x is greater than 0 and when f of x is less than 0. And this is going to be more intervals than the last time. So again, we're always looking left to right, so from negative infinity to infinity. So it looks like I'm above x from negative infinity to my first 0. So from negative infinity to negative 1.6, I am above the x-axis. And then from negative 1.6 to 0, I'm down below the x-axis in here. And then from 0 to 2.6, I pop above, so I'm going to write union 0 to 2.6. And then again, from 2.6 to infinity, I am below the x-axis. All right? And if you were doing increasing, decreasing intervals, it's really the same idea, except rather from going to your zeros, you would go to your changes in direction. All right? So that's it for those two problems. Here we're asked to write a cubic function whose graph passes through the given point. So you could do this two ways. First, you'll notice that all of these are zeros, right? So that is an advantage for us because we know in factored form we have a x minus, your zeros, x minus h, x minus p, x minus q, whatever you want to call it. We have h, p, and q. So I can go ahead and plug that in because these here are my zeros. This here would just be a point that I can plug in then to solve for a. So you would get y equals a, x plus 1, x minus 2, x minus 3. All right, so again, I'm still missing this a term. So I'm going to plug in the point 0, 9. So I get 9 equals a, 0 plus 1, 0 minus 2, 0 minus 3. And I'm just going to work this out. So 9 equals a times 1, negative 2, negative 3. 9 equals a times 6. Divide by 6. So you get 3 halves equals a. So then your final answer here, you could just leave it in factored form. 3 halves, x plus 1, x minus 2, x minus 3. And that would be your answer. And it's fine to leave it like that. All right, the second way you could do this, if I, let's see what I can do here. Take a picture. All right, with this is you could put this in the standard form, y equals ax cubed plus bx squared plus cx plus d. And then you're going to plug each of these values in for x in this equation and for y and set up a matrix equation. So what you would end up is y equals a times negative 1 cubed plus b negative 1 squared plus c negative 1 plus d equals 0. Really? I'll get rid of this. Y equals over here. Get a 2 cubed plus b 2 squared plus c times 2 plus d equals 0. A times 3 cubed plus b times 3 squared plus c times 3 plus d equals 0. And finally, a times 0 cubed plus b times 0 squared plus c times 0 plus d equals 9. Okay, so once you're here, you could just put it right into a matrix. So negative 1 cubed is negative 1. Negative 1 squared is 1. Negative 1, 1. Then I have 8, 4, 2, 1, 27, 9, 3, 1, and 0, 0, 0, 1. Here I'm solving for my A, B, C, and D terms. And now I'm going to set that equal to my solutions. That would be this over here, so 0, 0, 0, 9. And now we see we have a matrix AX equals B, so I can solve X equals A inverse B. So what we would do here is input this into my calculator. So I'd go to second matrix, edit, and I'm entering in a 4 by 4. I'm just going to go ahead and enter everything in negative 1, 1, negative 1, 1, 8, 4, 2, 1, 27, 9, 3, 1, and 0, 0, 0, 1. Okay, then I'm going to go to second matrix and I'm going to edit matrix B. And here's a 4 by 1, remember rows by columns. And I get 0, 0, 0, 9. And then I'm just going to quit out of here and actually do the math. So second matrix A inverse second matrix B. And you'll see if we were to multiply out our original answer, you'd get something very similar to this. So here, if you were doing it this way, your answer would be 1.5x cubed minus 6x squared plus 1.5x plus 9. And that would be your final answer. And if we were to multiply out our first one, you would get that as well. So you can do this either way. You can only do it this first way. Whoops, I'm sorry. If you have all 3 zeros here. If you don't have all 3 zeros here, you can't do it this way, but if you do, you can, and that's nice and simple. All right, this last one, this is where we're going to use finite differences. So all we're doing here is doing the second minus the first over and over again. So I'm going to do negative 31 minus negative 16, and that's going to give me negative 15. Negative 54 minus negative 31, so that's negative 23. Negative 79 minus negative 54 is negative 35. Negative 100 minus negative 79. I'm sorry, this is incorrect. Negative 79 minus negative 54 is negative 25. Negative 100 minus negative 79 is negative 21. And this would be negative 11. So this clearly did not work. So we have to go again. We'd get negative 8, negative 2, positive 4 and positive 10. So here, that did not work either. That was our second term. But luckily, we can see we're going to get the infamous 6, 6, 6 with our third try. So we know this is a third degree function, which is a cubic function.